So first of all, I would like to give two thanks. The first one is to you, the audience, to be here on a 3 p.m. afternoon of the second day, after 2 great days at the PRS. And the second thank is also to my company and the PRS also, who had allowed me to do this speech today about the route to higher PCR incorporation, which is, you know, a challenge which we've been working out at Dow. But I would have a key message before get started, is that the PRS show now is to become 3 days, because 2 days is not enough. I think I still have a lot of people that I would like to meet. Unfortunately, tonight it's the end. So I hope that for the PRS team that next year you would think about extending it to 3 days. Okay? And no presentation on the third day at 3 p.m. All right? So let's get started. So Recycling 4.0, and I will explain to you why Recycling 4.0 is about. The first slide, which is the usual one, talking about Dow. For the people who don't know us, we are a large petrochemical company. We are headquartered in Midland, Michigan, and we have sites all over the world. Actually, across Europe, we have 3 hubs in Terneuzen, Tarragona, Spain, and DCG, Central Germany, where we are producing our product. And you see the range of product families that we have here. Half of Dow is packaging and specialty plastics, which is the division I'm working for. And I'm based in Switzerland. I've been working for Dow 29 years, and I am heading mechanical recycling for Europe, Middle East, Africa. Now, as an ambition as Dow, we really want to conserve the carbon. We are not just talking about the linear economy anymore, which is really to make it circular, to talk about ecosystems, to marry advanced and mechanical recycling, to make sure that the carbon use and the carbon system are fully efficient, as we don't want to waste the waste. We all know that in recycling you have yields, you have performance, you have waste of the waste. So we are thinking differently into building hubs that will encompass major technology together to actually have a yield on waste which is largely above 90%, so that we don't waste the waste. So it is really about our journey on how we want to make this happen on a global basis, and doing it, of course, in Europe with you. Also, our ambition, which is extremely high. We have set the ambitions in 2022 that by 2030, we will make circular 3 million tons of polymers or scientific methods or systems to actually have 3 million tons of PCR, advanced recycling product, chemicals that are coming from waste that go back into the economy, so that in fact it represents a major milestone on our output. 3 million tons is not just a sample. It's actually, if you think about world-scale plant, it's equivalent to 5 to 6 world-scale plant. So for us, we are going to make it happen at several facilities across the globe with partners, so that we can achieve that goals and ambitious goals by 2030. But decarbonization is very important. So we have announced recently, I don't know if you've seen it, our first and major Path to Zero plant in Fort Saskatchewan, Canada. And we want to do the same outside of Canada as well, and to go into Europe, Asia Pacific, Latin America, where we will offer decarbonized polyethylene. Then you may feel it, okay, what those guys are saying, it is crazy, it has carbon inside the system. How do you decarbonize? Actually, the challenge here is really to make sure on the scope 1, 2, and 3 emissions, we really have a path to zero to make sure that our polymers have the lowest carbon footprint that you can find in the industry. Now, if you want to make things circular, you have to get started by the foundational work which already started since almost 10 years ago, where you try to transform non-recyclable systems, packaging, and product into recyclable ones. Even offering barrier material that are full polyethylene, even offering circular material that can go back into the same applications, making sure that when you shred and wash and clean those polymers, they can be used in the same application. Because there is still too much downcycling, and now we are looking to upcycle, to really go back into the same application, and I will show you some examples later. But these foundations was not possible without polymer science, without making sure that at the converting level, they get the material that can allow you to make it recyclable. So we have developed this system that was Recyclas approved last year, where we made a first barrier film that got Recyclas approved, which is a combination of polymer science and polymers in various layers. In that case, you have 7, where you can have full proof of barrier for food application, where you need to protect the food and the goods so that it doesn't perish. But still, when it gets to recycling, it gets shredded, washed, and cleaned, you can see that the gel performance will be very high, meaning that we don't have those big gels that are polluting the extrusion of films, producing the converting issues, and then ultimately printing issues, and then ultimately recycling issues. So this is what we have developed, and it has been Recyclas approved last year. Now, how do we work in mechanical recycling? Actually, on one hand, as a petrochemical company, you would tell yourself, okay, those guys are going to work on the polymer science on the right side of the chart here. But in fact, we have decided to work on those 5 pillars, which is about sorting, using new technology in sorting as well as artificial intelligence to better sort the waste, to make it available for the washing step to perform a better job. As Dow Industrial Solutions, our chemical business part, has developed new systems to clean and wash the flakes in a better way, so that at the end of the day, when it goes to the drying and then the extrusion, it contains much less leftovers of contamination, of dust, of any kind of stuff you can find into a recyclate. Then we have developed a family of compatibilizers. So those products are already used today a lot in automotive application, for example. They are used in consumer goods application and also in films that enable the molecules to mingle better together so that they can transform a recyclate, a PCR, which is actually much better in terms of quality performance. And especially when you go back into very thin films like 10, 20 micron films, for the ones that knows what extrusion is about, it's really a challenge. We've learned that going back to the same applications will be stopped if the quality of your PCR doesn't reach a certain level. And then we have developed also PCR now where we can report gels. We can report performance. They are certified by Recyclas and others, but really to make sure that we bring the peace of mind to our customers. So this is really our mantra. If you are a converter, what you are looking at is to use those resins into your large lines at scale. You don't want to have to stop them every 5 minutes. You don't want to run at 20% of capacity. You don't want to actually shred 50% of your film because it doesn't meet the requirements. So basically what we are offering is the peace of mind with Revolup, which is our brand of PCR product that are formulated or not. And they can offer high incorporation of PCR into the same application. You will show that we have made a breakthrough with our partner RKW, and we will present you the slide right after. But clearly here is to enable high run rate, high throughput into large lines, like those big extrusion line running at 2 tons an hour. They need to run 24/7. They cannot be stopping every hour and then restarting and then decontaminating it. It doesn't work. So of course, credible certification has been worked out so that we make sure that the product you buy is also traceable. The traceability has been certified, and we are not playing with the claims. When we talk about PCR in Dow, it's post-consumer. Will it be household? Will it be commercial waste? It's a different story, but it's not post-industrial. So we want to make sure that we are clear about this. So now let me move to the case study. So I have 2 case studies to show you. The first one is not this one, it's actually all the family of boosters that we are selling in the automotive industry to really change the game into polymer science when you want to recycle back into the same applications. For example, what about having a bumper which is made of an old bumper? For that, you will need very advanced polymers to modify the structure, to make sure that the compatibility between the PCR and the virgin works extremely well, and that the overall performance is certified. So we have a family of products like the Fusabond, the Surlyn, the Engage, Intune, Infuse, that are here to enable this. So some of these products are tuned to different applications. Will it be wire and cable? Will it be pipe? Will it be automotive interior, exterior elements? So this is what we are offering, actually, to compatibilize also other polymers than polyethylene. Could be about polypropylene, polyester, polyamide. All of these polymers, generally, they don't mingle well together. So using advanced booster can help you to make sure it can be recycled and it can go into a similar application. So 3 family of products that we have developed for packaging here and also for artificial turf that are commercial today. So in the past, we were developing only formulated resins that were compounded with virgin and PCR. So we have developed now a new family of products which is not compounding, which is 100% PCR, that we are launching on the market actually at the fair. And we can go into the same applications like collation shrink films, like stretch films, like artificial turf, where we actually increase the level of incorporation of PCR without affecting the end application. And it was really challenging, to be honest, because of the gel issue, which is a major problem all of the converters have with PCR that we try to fix by tuning the product in a way that we can offer you a low gel PCR resin. So that low gel PCR enabled us to develop this one that I said earlier with RKW that was launched just at the show, where it's a first of its kind 70% PCR content collation shrink film for the 6-pack that we call My Multipack. Why? Because it contains the waste from your yellow bin at home. It's actually direct from the bin. It's not just a commercial waste that is coming out of an industry, which is very clean generally. It's part of this waste is coming from the yellow bin and has been transformed into Revolup resins that are allowing very important things. Is first to go in collation shrink film applications that can be extruded into a world scale extruder, can be printed, and can be going through the shrink tunnel so that it can become a 6-pack. This film has 35% commercial waste-based PCR, 35% household waste-based PCR, and 30% of virgin to make sure it can do the job, and also it can remain transparent. Because most of the household waste-based PCR today are likely to be colored, being white, black, gray. So this one is, as you can see, is fully translucent, is doing the job on the shelf for on-shelf differentiation, and it can also pack at high speed your bottles, your containers, and it's actually implementable right now. Second case study is actually to look at how bags overall, heavy-duty shipping sacks, can go back into the system as well and still do the job as a high-performance bag. When you carry a 25-kilo load, you cannot make mistakes, because otherwise what happens, you get spills, loss of containers, and then you get a claim, you get a QM, and then at the end of the day, it can cost a fortune if the truck is actually have a spill. So here we've been working with Armando Alvarez to develop this new bag containing 30% PCR, but also remaining extremely thin, like if it was with only virgin. It's the same thickness. We didn't increase it, we keep it the same, and we can do the job and reusing at Dow inside our factories to reship the product externally. So it's a loop that has been created to offer peace of mind as well for our customer, because don't forget that we want to make sure you have EHS safety, meaning you don't have harmful product leftovers in the PCR. You don't take the risk that your product is contaminated. So those products have been certified by Dow, Product Stewardship, so that you don't have any issue furthermore and down in the value chain. So we call it a SAC for life because actually it can be extremely circular and extremely virtuous. This can be implemented and repeated at every locations that we have, at every steps in our value chain, which is to manufacture and ship product. Now, what is recycling 4.0? You know, it's the title of my presentation, and you may say, okay, what this guy is smoking? No, I'm trying to be clear that here we are thinking about associating mechanical and advanced recycling under the same roof. So it's pretty disruptive because most of the recyclers are either mechanical recycler or advanced recycler. Here, we have one of our partners, which is the company Valoragen in France, which we have announced 2 years ago, has put under the same roof the two technology. The advanced mechanical recycling process, if I may say, as they have sorting, washing, extrusion, decontamination, and the leftovers of mechanical recycling in the factory will go into the advanced recycling part. In that way, you don't ship waste too much. You ship waste at one location and it gets transformed into PCR, and the leftovers are being transformed in a pyrolytic oil that will become a new feedstock for Dow to transform and to create new polymers ultimately. This is really showcasing a very high reduction on CO2 emissions because we don't ship and lose waste. Actually, the yield on this operation will be higher than 90%. There will be almost no leftovers of waste that will go out of this company. So they've been applying different technology, as you can see. One of them is advanced sorting to make sure that the filter of sorting is done before it's rerouted to the advanced mechanical part or the mechanical. And then with that backbones of polymers, the PCR, we will produce Revolup, which is our branded product that are based on post-consumer recyclate. And the other stream, which is pyrolytic oil, will be used to produce new virgin-like, innate, affinity, engaged resins that are here to do the job in more sensitive applications like food and medical contact applications. So those two technologies are very more, I would say, optimal to reduce carbon emissions. Because in fact, the collateral energies from one step to another can be recycled into the system to make sure that you don't lose carbon. So they have put in place a smart energy management systems because you have collateral energy from the two systems. So this is where we want to achieve our goals, is to offer the lowest CO2 footprint, PCR, as well as advanced recycling resins. Now, all of this cannot happen with Dow alone. It's always about collaboration, learning from each other, developing partnerships that are extremely strategic to go to the next level. Because Dow, we are not a waste manager. Dow is not a mechanical recycler. Dow is a polymer scientist. So what are the backbones that are missing? We need to acquire them with partnership that are equipped with the latest technology. So that's the way we partner with companies in Europe. So we have actually several partners that we have announced in order to make sure that we have sufficient supply of those polymers. That the PCR we offer at that scale, it's very often the question I receive from converters. They show me the case and they say, okay, but is it a sample or it's real? And I'm telling them, yes, it's real. It's something I've been securing with key partners across Europe so that from a logistics standpoint, we are able to supply across Europe. But again, it cannot happen alone. It's really an invitation to collaborate and to differentiate together. and also to bring new solutions so that we don't call about just simple mechanical recycling, but it's advanced mechanical recycling as well as advanced recycling together. So now we can have questions, Q&A if you want. Thank you for your time and your attention on this 3 p.m. It's late.
I had a question, since you mentioned France, about Citeo. Have you done anything with them, or just Recyclas?
We talk. We talk with Citeo, of course, and with the various EPR schemes in Europe. You know, Corepla in Italy, EcoAmbes, and you know, so Force Plus. So we have collaboration, but really more to understand what are the requirements to make circularity real. So generally, what we ask is that there should be a regulations which is really sure making the different scenarios possible. Because if you apply, for example, principles like you say, yeah, we want 50% PCR content in a film, in a packaging, but that the regulation is not enabling it or is not incentivizing financially, it won't work. We've seen it last year when virgin materials became very cheap. And of course, there was a temptation to go back to virgin materials, which is the economic picture playing, this basket here. Now, when you talk about circularity, it's more complicated to use alternative materials. So basically, we need to develop also the legislation that is incentivizing the use of PCR, the use of alternative materials.
Thank you for the presentation. I have maybe more clarifying question. You just at the end mentioned you are not a recycler, you are a chemical company, but in the picture before you showed that there's a mechanical and chemical recycling plant. Is that a DAO plant or is it a partner's plant?
It's a co-investment plan.
Okay. So, okay. So
to
DAO,
make it simple.
DAO is involved and invested in this plan too?
Yeah, yeah.
Okay, thank you.
Yeah. Thank you very much. Okay.